Hello, thank you very much to all my subscribers in my YouTube channel. Now I'm going to present cementing designs for HPHT wells in soil gas productions. This is a case scenario real in South America about liner design, yeah, for a well that produces soil gas with CO2, H2S, and mercury. Very high risky soil gas production. So I will show you all the tools available in my YouTube channel, and also you can find me in LinkedIn under my complete name. So the cementing design. This is a software that I create based on last company that I work at. Okay, so let's go to start with the simulation. This is the spreadsheet that I can share with you all that subscribe to my YouTube channel. Of course, first of all, we need to design the fluids that we are going to use in the liner production cementing operations. That means that we are going to need to calculate and design cement slurry, what type of slurry we are going to use, main slurry, lead slurry, the density, the rheology is very important. Also the spacers, if we are going to use mechanical spacers combined with chemical spacers, how many barrels, what's the density, the rheology, this is very important, for our cementing operations. And finally, the drilling map that is going to use, and the final fluid displacement. Everything is in this spreadsheet, how we are going to calculate, okay? And also, we have the rheology for each fluid, okay? That you can also check in your laboratory when you have the availability to check the values, okay? This is the well schematic, okay? This is a HPHT well, as I mentioned. Okay, the depth is in meters. You can see here is around 3,400 meters of measured depth. Okay, and inclination is average 16 degrees. So we can calculate the hydrostatic and the dynamic conditions. Here, don't worry about the language of this software. Already I'm translating everything to English, and next in Arabic and French, of course, next year. Okay, we have here all the, if you can see, all the property of the fluids. Remember that for cementing, okay, for hydraulics, the ECD calculations, we need to use, okay, the Reynolds numbers. And we have three types of flow designs, turbulent, plug, and norm. So here is all the calculation. Just only this is all the tabs are linked to the rheology and of course the properties that we are going to use in the cementing operations. Every tab, can you see here is according, if you see the different change of colors, is because the movement of the fluids when we are going to perform the operation cementing. That means that every tab, okay, you can see here, calculate the ECD in dynamic conditions, okay, to operate under the normal windows, that is always, or ECD must to be over the reservoir pressure. Why? Because we need to control the well to avoid any gas inflows, to prevent any blowout. And always here is the reservoir pressure. Okay, in these calculations, we calculate in density, ppg, pounds per gallon, and here is the frag density. You can calculate frag pressure, frag density is normal. So the operation, this is the window of operation that our pumping circulation in bottom hole treating pressure must to be over the reservoir pressure and below the frag gradient. Of course, in cementing operations, we never will go to overpass the frag gradient because which should be a problem similar than if we have, okay, the EZD, okay, below the reservoir pressure. So always must to be above, yeah, to avoid any influx. So that's why in this spreadsheet, okay, we can calculate the pumping rate, okay, the volume of cement, and also the time that we are going to need to perform these operations. Remember the basic concept of all the fluids. For a spacer, for example, we need at least, okay, this is the well schematic, at least 10 minutes of the fluid contact between the open hole section and the OD of the casing or liner to have a very good clean and adherence of the cement into the casing and into the formation. Also, there is another standard global best practice that should be at least 1,000 feet of length to calculate the volume of the spacer, okay, and also according the pumping rate. That's why we have in the simulation the pumping rate and the volumes, and we have the surface pressure also. This software made also with the help of a good engineer in Bolivia, okay, is very similar the results with big service company that they have software around the world. So really thank you very much. I wait for you in my YouTube channel. Thank you.